Alright, this is 3.8. We're solving problems 12 through 24, multiples of 3. Alright, let's start with number 12. This problem says, if 4 gallons of pure ethanol are added to 46 gallons of 2% ethanol, how much of the final solution do you have? How much ethanol is contained in the mixture? And what is the strength or percentage of the ethanol in the mixture? Okay, so what we're looking at is a pure version of ethanol or gas and a 2%. We're going to take some pure and some 2% and we're going to mix them together. So what we are concerned with here, what we need to answer is, first of all, how many gallons are we going to have of each? Okay, then they want to know the percent of ethanol in each gallon. Okay, sorry, so then we have the percent of each one, and then basically what they want to know is the percent per gallon that you're left with once you mix it. So a couple of things that we know about the problem, if we look at it again, we've got 4 gallons of pure ethanol. Now pure ethanol means it is 100%. Now I don't want to deal with percents when I am doing my math, so I'm going to go ahead and turn it into a decimal. When I move that over 2 to the left, that gives me 1. So if I look at percent per gallon of pure ethanol, that means 4 times 1, or all 4 gallons are complete ethanol. That's how much ethanol is in those 4 gallons. All 4 are pure. So for the 2% ethanol, they tell us that they're adding in 46 gallons of 2% ethanol. Now, so what I want to do again is move that decimal over 2. That gives me 0.02. And then to figure out how much of the 46 gallons is actually ethanol, I want to take 46 times 0.02, right? So I'm just going to multiply these. So that is going to tell me okay, yeah, 0.92. That's how much of the 46 gallons is actually ethanol. All right, so as far as the questions about the mix, how many gallons will be 4 plus the 46? That gives you 50 gallons of this mixture of the two. Okay, and then we do not know what the percentage of the 50 gallons is going to be, so I'm just going to put like an X here for that percentage. We don't know, but what we will know is that when we take that percentage times the 50 gallons, it's going to give us how much is of the percentage of the gallons is actually ethanol. Okay, so we have taken the pure and the 2% and we've mixed them all together to make the mix. So I'm going to take the 4 plus the 0.92. I'm just going to go ahead and add those together. So I've got 4.92 here. That's how much of these two are actually ethanol that are mixed in. And those together equal the total 50 gallons at whatever percent 4.92 is of the 50. So from here, of course, I will just divide by 50. And that percentage is going to be, it says 0.0984. So, but again, I want a percentage, so I'm going to move this over 1, 2, and that gives me 9.84%. So that means out of all 50 gallons, 9.84% of it is actually ethanol. So again, if we look at your questions, it says how much ethanol is contained in the mixture. So your first answer here is going to be 4.92 gallons. Okay, that's how many of gallons of the 50 are actually ethanol. Then it asked, what is the strength or percentage of ethanol is in the mixture? And that is 9.84%. Oh, and I'm sorry, the first question asked, how much of the final solution do you have? So the mix was actually 50 gallon. All right, so those are your 3 answers here for number 12. Remember, you can pause at any time if it goes too fast, so I'm just going to keep going to number 15. All right, number 15 says, Mr. Harper, the candy store manager, wants to mix butterscotch candies and cinnamon balls to make a deluxe mix to sell for $3 a pound. Butterscotch candy sells for $3.40 a pound, and the cinnamon balls sell for $2.90 a pound. How many pounds of each should he use to make 20 pounds of the mix? Okay, so clearly we're going to take some butterscotch and we're going to take some cinnamon candy. We're going to make this deluxe mix that he's looking for. Some of the things that we know is we need to know how many pounds of butterscotch and cinnamon we need to make 20 pounds total of the mix he wants. Okay, the next thing we need to know is how much per pound these cost, because he wants the mix to cost $3. Okay, and then what we're going to take is the I guess what we'll do is we'll say the price per pound, right? We'll multiply those together. So we do not know how many pounds of butterscotch or cinnamon we need, but we do know that we need 20 total. So if we say we don't know how much butterscotch we need, but we know that the cinnamon will be 20 pounds minus whatever the butterscotch is. Okay, we know how much we need total, so just make one unknown, make the other 20 minus the first one, and then that will end up giving us our 20. Now, digging back in the problem, it says that butterscotch is $3.40. Cinnamon balls are $2.90. So pounds times the price gives us our price per pound. So for butterscotch, we're going to say 340x. Now for cinnamon, we'll do 290 times 20 minus x. And then for the mix, we're going to do 20 times $3 a pound, so that's going to be 60. Okay, so now we need to set it up. Now we know this one's a little easier because we know we're going to take the butterscotch plus the cinnamon, right? We're going to take this plus this, and it should equal $60, right? But what we need to figure out is how many pounds we need. Now we know about prices, we know total price, we have a lot of information, we just need to put it all together. So we're going to take the butterscotch price. By the way, so when you're dealing with decimals, a 0 at the end does not make a difference when you're multiplying, adding, all of that good stuff. So you can go ahead and just shorten this to 3.4x. It's probably what the math book would say. So 3.4x, and then we're going to say plus 2.9 times 20 minus x. And that should all equal 60. Butterscotch plus the cinnamon balls, $60. Okay, so let's drop 3.4x, and we're going to add the 2.9 times 20. So that's going to be 2.9 times 20 will give us 58 minus 2.9x, all equal to 60. Okay, so when you start dealing with decimals in these, what you might want to consider doing is getting rid of them. So you have decimals only to the tenths place. So usually what would be easy to do is to take your problem and you can multiply everything times 10, and that will give you your number without decimals, and it will all even out. So everything is times 10, then it's equal to what you had before. The difference is equal. So if we walk through here and we say 3.4 times 10, we should end up with 34x. 10 times 58 will give us 580. 2.9 should become 29x, and then 60 becomes 600. Okay, so those numbers are just a little more user friendly to work with. Alrighty, so what we'll do now is we're going to take our like terms, 34 and negative 29 will leave us with 5x plus 580 is equal to 600. All right, we want x by itself, so we're going to subtract the 580 on both sides. Bye-bye. We're left with 5x is equal to 20. Divide by 5, and x is equal to 4. Okay, so what we can do with this, now as far as your answers are concerned, so butterscotch will be 4 pounds. What we know about the cinnamon is that we're going to take the 20 minus the butterscotch, so that gives you 16 pounds of cinnamon. Okay. And that should be it. Yep. And those are your answers for number 15. All right, number 18. Number 18 says, Chase has 3 gallons of a solution that's 30% antifreeze, and he wants to use to winterize his car. How much pure antifreeze should he add to a solution to produce a solution that is 65% antifreeze? All right, so looks like we're going to have a couple of things here. First, we're looking at 30% antifreeze. Then they're asking how much pure antifreeze will he need to add to his solution. So we're mixing these two. Okay, so I'm going to go ahead and just say I'm comparing the 30% to the pure to the mix. All right, now some of the questions they're asking is how much should he add to the solution to produce a solution that is 65% antifreeze. Okay, so let's start with gallons or percent. Let's start with gallons, how many gallons we have. And then let's start with what the percentage is. And then what they want to know is how many of the gallons are actually antifreeze. Okay? So let's just take those and go with what we know. So for the 30% antifreeze, it says that he has 3 gallons. Now, for percentage, we know that it's 30%, but as usual, we're going to take our percent and we're going to make it into a decimal. And then if we have 3 gallons, that is 30% or 0.3 actual antifreeze. I can take these and that will tell me when I multiply it that the actual only 9/10 of those 3 gallons is actual antifreeze. All right, so for the pure, they want to know, what they want to know is how many gallons they should add to it, right? So I don't know, but I do know that it's 100% antifreeze. So again, I'm going to move over to, so that gives me a 1. My gallons per my percent, x times 1 is still x. Okay, and so how much pure antifreeze should he add to this solution to produce one that is 65% antifreeze? And that as a decimal will be 0.65. So here, whatever my mix is, it's going to be, we don't know how much, right? We don't know how much it's going to be because we don't know how many gallons of pure we have. But what we do know is that we're going to take the pure and we're going to add the 3 gallons of 30%. Okay, so what we can put that together. We can say, okay, how many gallons of actual antifreeze will be in this mix would be the 0.65, and we can multiply that times x plus 3. Okay, and that will give us 0.65x plus, so 0.65 times 3 is going to be, let me put that in the calculator, 1.95. Or, you know what, let's leave it like this going out. Okay, so we're going to take our gallons of antifreeze. So I'm going to say 0.9. And then I'm going to add, so I'm going to take the 30% plus the pure. So that'll be 0.9 plus x. And when I add these two together, I'm going to get the 0.65 times x plus 3. Okay, so what we're going to want to do here is the same thing we did last time. We're going to go ahead and get rid of our decimals. So we're going to take everything and we're just going to multiply it by 10. So I'm going to take all of this and multiply it by 10. So that will give me 90 plus 10x is equal to 65 times 10x plus 30. Okay. Oh, you know what? No, I'm wrong here. So, yeah, I forgot a quick rule. If you are multiplying the 10 into everything, things inside parentheses are actually safe. So that will stay x plus 3. My bad. Okay. Good reminder for that. So let's go ahead and I've got 90 plus 10x. No, something's wrong. Okay, hang on one second. All right, what we're going to do actually is multiply this by, okay, we're multiplying it by 100. That's where I got the 90. That will make this 100x, and that will make this 65. So if I take 0.65 times 100, because I'm at the 10th 100th place, we're multiplying everything by 100 because we're at the 100th place here. So that will give you the 65. Otherwise, if you said times 10 to 0.65, it would be 6.5. So that's how we got the 65. My bad. All right, and so let's go ahead. I've got 90 plus 100x, and that's equal to 65 times x plus 65 times 3 will be 195. All right, so let's start moving our x's over. I'm going to subtract the 65x here. That gives me 90 plus 35x, and that equals 195. Let's subtract the 90, trying to get that x by itself, and that will leave you with 35x is equal to 105. And we'll divide by 35, and x will be equal to 3. Of course, we know we're talking about gallons, so our answer will be 3 gallons. So if A is equal to 3 gallons, then that means our total mixture will be 6 gallons. And let's make sure it didn't ask anything else. How much pure antifreeze should he add? Oh, okay. So actually, let's not add that up. They want to know how much pure antifreeze, so we're going to say 3 gallons pure. Okay? Let's label that this way. That will be our answer. They want to know how many gallons. Again, it's always good to go back and check your questions again. They want to know how many gallons of pure ethanol they're dealing with, or sorry, pure antifreeze, so that's going to be 3 gallons of the pure. 6 gallons total, but they did not ask that. Alright, let's take a look at number 21. Okay, this one says a chemist has 2 liters of a solution that's 10% hydrochloric acid, and she wants a solution that is 25% hydrochloric acid. How much concentrated 37% acid must she add? Okay, so there's a lot going on here, so let's look at it again. She has 2 liters of a solution that is 10% hydrochloric acid. Okay, so we know, all right, so we know what we have is the 10%. It says she wants a solution that's 25. Now, so this is what she wants to make. So, so this is going to be the mix, the 25% mix. Okay, so I'm just going to put it like that. Then it asks how much 37% concentrated hydrochloric acid should she add? Okay, so she's got the 10%. She wants 25%. How much of the 37% should she add in to get what she wants? So the first thing that we are told is that they actually have 2 liters, okay, of the 10%. And then what we want to know is the percentage of hydrochloric acid, and that is going to tell us what the percentage per liter is going to be. So let's take a look at, make sure I set that up correctly. Okay, yeah, I think that looks good. All right, so for the 10%, I do know what my percentage is. I'm going to go ahead and move that decimal over to give you 0.1. And 2 times 0.1 will give me, let's just do this for now, and we'll get the calculator out. Okay, so I'm looking at the 37%. I do not know how much I need of that. That's my ultimate question. Okay, but I do know, again, my decimal for that will be 0.37, and that my percentage times however many liters I get will look like 0.37x. And that leaves my mix. So I don't know how much my mix is, but I do know that it will have the 2 liters of the 10%, and then I'll be adding in however much of the 37% I need. Okay, so for that, let me see. I know that they want the mix to be 25%, so move that decimal again. So I know they want it to be 0.25x. So my percentage per liter will be 0.25 times 2 plus x. All right, so the other thing that I know here is that I'm going to mix these 2 top hydrochloric acid. So I'm going to take the first one, I'm going to add it to this one, and they should equal this. Okay, so let's set that up. So I have 0.1 times 2 plus 0.37x, and that should be equal to 0.25 times 2 plus x. One of the reasons that I did not go ahead and solve these is because, again, we have decimals. So I kind of flew through the other one incorrectly, but again, if you want to get rid of your decimals, you need to multiply to the place value of your decimals. So again, you've got tenths and then hundredths. So what we're going to do is we're going to take this equation and we're going to multiply it by 100 in order to get rid of our decimals. Again, anything inside a parenthesis is off limits, so we will only be multiplying times the items that are here. So 100 times the 1 will give us a 10. 2 is not touched. We'll add that to, again, I'm moving over my decimal when I'm multiplying by 100 to 37x. And that's going to, again, move over this decimal to 25, and everything inside the parentheses is not touched. All right, so 10 times 2 is 20, plus 37x is equal to 25 times 2 is 50. 25 times x is 25x. So now from here, you'll just start moving over your like terms. So we can start with our x's. It really doesn't matter. Let's go. We're going to subtract the 25x on both sides, canceling on the right. That's going to leave us with 20 plus, let's subtract that, 12x, and that's equal to 50. Okay, we want x by itself, so let's go ahead and subtract the 20 on both sides, canceling on the left, and that's going to leave us with 12x is equal to 30. Divide by 12, canceling on the left, and x will be equal to 2.5. Okay, and we're going to label those liters. So if I'm looking at the problem again, it says how much of the concentrated 37% acid must she add? So this is going to be your answer. We're just solving for x. All right, that was 21. So, 24, and then we are done. All right, let's take a look at number 24. Okay, this one says, a butcher makes meatloaf by mixing hamburger, which sells for $1.89 a pound, and sausage, which sells for $2.99 a pound. How many pounds of each should he use if he makes 30 pounds of the mix and sells it for $2.33? Okay, so this one's pretty straightforward. What we have is hamburger meat, sausage, and then he mixes those. Okay. What we know is that we need to figure out the pounds. They told us how much it is per pound. So we'll come up with a price per pound. Some things that we do know let's read back through it. It says that he mixes the hamburger that sells for, $1.89 a pound. Okay, we're not going to put anything here in that yet. He mixes that with sausage that sells for $2.99. He wants to know how many pounds he should use if he wants to make 30 pounds of the mix and sell it for $2.33 a pound. Okay, so this one will work a little bit like it will work like the hydrochloric acid. We don't know how many pounds we need of the burger or the sausage, but we do know we need 30 total. So we'll just say, I don't know how much the burger is. I don't know how much burger I need, but whatever it is, the sausage will be 30 minus the hamburger, so whatever's left over. So we'll go ahead and set up price per pound. So it'll be pound times price, $1.89 x. Sausage will be $2.99 times 30 minus x. And then the mix will be 30 times 233. All right, so okay. Yep, looks good. Okay, so again, we'll be taking the hamburger and adding it to the sausage, and then it equals the mix. So we're going to go ahead and set that up. 189x plus 299 times 30 minus x, and that'll be equal to 30 times 2.33. All right, and I'm actually gonna keep everything in the right order. So if we're putting the price per pound, I'm gonna go ahead and flip-flop these. So we'll put the 30 here, and we're gonna put the price here. And so ultimately, the reason that I'm fixing that is that, again, we're going to get rid of our decimals. So I don't want the decimal in the parentheses. I want it to get fixed. So that's why I notice it's like kind of a different order. So we're going to take all of this and we're going to multiply by the place value we have of our decimals. So again, tenths, 100ths. So I'm going to multiply by 100 throughout everything. And again, the parentheses are off limits. So that's going to take me to 189x plus 299 times, keep that 30 minus x. That's going to equal 233 times 30. All right, decimals are gone, so let's go ahead and solve here. So 189x plus, so 299 times 30 is equal to 8970 minus 299 times x, 299x, and then 233 times 30 is equal to 6990. Okay. All right, so let's go ahead and start combining some like terms. Now, what we do have on this side, we already have two like terms, so I'm going to take this, and it looks like we're going to do some subtracting there, ending up with a negative number. So I've got a negative 299, and I'm going to subtract 299 minus 189. That's going to be negative 110x. Don't forget that the 299 is negative and it's bigger, so I'm going to have negative 110x plus the 8970, and that equals 6990. Now, I want to take the 8970 and we're going to move it over. So if I subtract that on both sides, so what you can see here again is you're going to end up with a negative number, so that it's going to work out because a negative divided by negative is a positive. All right, so let's do 8970 minus 6990. Okay, so that's going to give us a negative 1980, which I will divide by 110 on both sides. So I'm going to just cancel these, and x is going to give us 1980 divided by 110, a positive 18. So that tells us then for our answer for hamburger, I guess you better say hamburger, we need 18 pounds. Now let's just do 18 pounds. And that means for sausage, you need 30 minus 18 is what, 12? 12 pounds. Let me just check our answer. 24. Yep, and that is correct. So there's your answer. All right, have a good one.